Welcome to all of you in this video lecture. I am Shailesh Shankar Birajdar, working as an assistant professor in Department of Mechanical Engineering from Walchand Institute of Technology, Solapur. In this video lecture, we are going to discuss classification of hydraulic turbine. Learning outcomes. At the end of this session, student will able to understand what are the different types of hydraulic turbine. Content. In this video lecture, we are going to discuss what is power producing device. Second, what is turbine, what is hydraulic turbine, what is working principle of a hydraulic turbine, and we are going to discuss classification of hydraulic turbine. So first one is power producing device. Dear, as we know, there are two types of devices. One is a power absorbing device and another is a power producing device. The devices which are used to absorb the power for producing the work, that devices are called as a power absorbing device. The example of power absorbing device is a pump and compressor. And the devices which are used to produce power is called as a power producing device. The example of power producing device is a water turbine, internal combustion engine, and boiler. So these are the image of water turbine, internal combustion engine, and boiler. Next one. Now I will tell you what is a turbine. So turbine is a power producing device. It is a prime mover. It is a rotating mechanical device that extracts the energy from a fluid and convert into useful work. A fluid is allowed to flow through the turbine. So according to the type of fluid flow in the turbine, turbines are mainly classified into three types. One is water turbine, second one is gas turbine, and third one is steam turbine. Now I will tell you what is a hydraulic turbine. So hydraulic turbine is a hydraulic machine which convert hydraulic energy of a water into mechanical energy, and this mechanical energy is further converted into electrical energy. So the definition of hydraulic turbine is it is a device which convert hydraulic energy into mechanical energy, and this mechanical energy is converted into electrical energy with the help of generators. Now we are going to discuss what is working principle of hydraulic turbine. Working principle of hydraulic turbine depends upon the Newton's second law of motion, which states that the force is directly proportional to the change in momentum. See here, this is the diagram of hydraulic turbine. The water is stored in the dam. The water is coming from the dam through the penstock, and it strikes on these blades of runner. When it strikes on the blades of this runner, that time these blades are displaced, and therefore resulting force is created here. So due to this resulting force, these blades are start to rotate, and this runner is coupled to the electrical generator, and we convert the mechanical energy of this runner into electrical energy. So here we convert the potential energy of a water into pressure energy and kinetic energy, then it is converted into the mechanical energy, that is nothing but rotation of this rotor, and then mechanical energy is converted into electrical energy with the help of generators. So this is the working principle of hydraulic turbine. Now we are going to discuss classification of turbine. The turbines are mainly classified according to four types. The first one is according to hydraulic action. So there are two types. One is a impulse turbine, second one is a reaction turbine. Second, according to the direction of flow of water, there are four types. First one is a tangential flow, second one is a radial flow, third one is a axial flow, and fourth one is a mixed flow. Third type, according to the water head and discharge of flow of water. So there are three types. First one is a high head and low discharge. Second one is a medium head and medium discharge. Third one is a low head and high discharge. And last type is according to specific speed. There are again three types. One is a low specific speed, second one is a medium specific speed, and third one is a high specific speed. Now I will explain one by one each. The first one is according to the hydraulic action. So as we know, the water has three types of energy. Based on the Bernoulli's theorem, water has three types of energy. First one is a pressure energy, then potential energy and kinetic energy. So depending upon the type of energy at the inlet of turbine are classified into two types. One is a impulse turbine and another is a reaction turbine. So impulse turbine, if the inlet of the turbine only kinetic energy is available, then that turbine is called as a impulse turbine. And the example of impulse turbine is a Pelton wheel turbine. And if at the inlet of turbine both kinetic energy as well as pressure energy is available, then that turbine is called as a reaction turbine. And the example of that reaction turbine is a Kaplan turbine and Francis turbine. Next one, according to the direction of flow of water. So there are four types of direction of flow of water. See here, this is the image of runner, and if the water flow tangentially to the runner, then it is called as a tangential flow turbine. And if the water flow in axial direction, means parallel to the direction of shaft of the runner, then it is called as a axial turbine. And next one is a radial turbine. If the water flows in radial direction, then it is called as a radial flow turbine. So the first one is tangential flow turbine. If the water flows tangentially to the runner, means water touch at the one point of the runner and then it leaves, that time that turbine is called as a tangential flow turbine. The example of tangential flow turbine is a Pelton wheel turbine. Next one is a axial flow turbine. If the water flows axial direction, means here in this image the shaft axis is horizontal, runner shaft axis is horizontal, and water flow parallel direction to the axis of turbine, then it is called as a axial flow turbine. The example of the axial flow turbine is a Kaplan turbine. Next one, radial turbine. If the water flows in radial direction, then that turbine is called as a radial flow turbine. So there are two types of radial flow turbine. One is a inward radial flow and another is a outward radial flow. So old Francis turbine is an example of radial flow turbine. Last one is a mixed flow turbine. In mixed flow turbine, the water enters radially and leaves axially. Then that turbine is called as a mixed flow turbine. So this is the image of mixed flow turbine. Here water enters radially and leaves axially. Now we are next type, according to the direction of flow turbine. Already we discuss. Next, according to water head and discharge flow of water. So there are three types. One is a high head and low discharge. Second one is a low head and medium head and medium discharge. And third one is a low head and high discharge. So discharge is opposite to the head. So in first, high head and low discharge means if the water head is available more than 250 meter, then that it is called as a high head and low discharge. The example of high head and low discharge turbine is a Pelton wheel turbine. And next, second one is a medium head and medium discharge. If the water head is in between 60 meter to 250 meter, then that turbine is called as a medium head and medium discharge. And example of that turbine is a Francis turbine. So this is the image of Francis turbine. Next, low head and high head discharge. So if the water head is below 60 meter head, then that turbine is called as a low head and high discharge. An example is Kaplan turbine, and this is the image of Kaplan turbine. And last one is according to specific speed. So there are three types of specific speed: low specific speed, medium, and high specific speed. Now I will tell you what is the specific speed. So specific speed is different than unit speed. So specific speed of a turbine is defined as those speed which are identical with the turbine, but it is an imaginary turbine and which will produce 1 unit power under 1 unit head. If the specific speed is below 60, then it is a low specific speed turbine. If the specific head between 60 to 400, then it is a medium specific speed turbine. And last one is if the specific speed is above 400, then it is a high specific turbine. Thank you.